Hello and welcome to this video that covers the Physics and Maths Tutor representation of data questions, questions 1 to 5. First question, a teacher selects a random sample of 56 students and records to the nearest hour of the time spent watching television in a particular week. So hours is on the first row, frequency on the next one, and we've got the midpoint of some of the hours here. So hours is essentially our class that's going to be in the x-axis if we were to make a histogram. So find the midpoint of a 21 to 25 hour group and 31 to 40 hour group. So the first thing to do is not to fall into the trap of just finding the midpoint of these values as they are, because as we can see, there is not an overlap between each of the classes. So here we've got 11 to 20, and then start at 21 to 25. However, we can see that this is a continuous data set, so therefore there must be a point where we're going to round up between 20 to 21. So we know that if you had a number line, you had 20, you had another one of 21, at the halfway point you're going to round up to 21, so at 20.5. So therefore the lower class bound of that class is just going to be 20.5, and then on the opposite end you've got 25 to 26. Well, at 25.5 you're going to round up to 26, so therefore the upper class bound is going to be, we just take it as 25.5, even though technically speaking you know that you would, if you get a value of 25.5, you would round upwards. Here it implies that the upper class bound is obviously the next value that would go, so it's the end of this class, and it's the beginning of the next class. So here the midpoint, when you're finding the midpoint, you've got to take into consideration the lower class bound and the upper class bound. So you would do 25.5 minus, well, you can find it in multiple ways. So 25.5 minus 20.5, which equals 5. So that's the difference between it, and then 5 divided by 2 is 2.5, and then add 20.5 plus 2.5 equals 23. So the midpoint between these ones is just going to be 23. The other quicker way of doing it is just to do the midpoint as you would do if you're finding the midpoint between 2 points, add them up and divide it by 2. But the first one we've got is 23. The second one here, between 31 and 40, again, we look at the class bounds between 30 and 31, so that suggests that the number in between, 30.5, represents the lower class bound of 31 to 40, and then we've got the upper class bound here, 40.5, between 40 and 41. So then you just add these two together, so 30.5 plus 40.5, divide them by 2, and you get a value of 35.5. And that is your two answers here. The next one, a histogram was drawn to represent these data. The 11 to 20 group was represented by a bar of width 4 centimeters and height 6 centimeters. Find the width and height of the 26 to 30 group. Okay, so the first thing that we have is the 11 to 20 group. So the reason, again, why we really want to be careful here is because when we drew our histogram, if we were to do a histogram and we were to draw the 11 to 20 group. So the 11 to 20 group, 11 to 20 group, when we would draw this, it's not going to be 11 to 20. It would be 10.5 to 20.5, and then this would be your bar essentially that you would draw on here. So just be careful when you're doing histograms that you take the lower class bound and the upper class bound when you're plotting. So here it tells us that it's got a width of 4 centimeters and it's got a height of 6 centimeters. And what we want to do is find the width of the height of the 26 to 30 group. So the 26 to 30 group is actually going to be made up of, we'll have a lower class bound of 25.5 and an upper class bound of 30.5, and has a frequency of 13. So there's 13 here. In this one, the frequency in the 11 to 20 group is 15. So how can we use this information? Well, first of all, we need to do the measurements. So first of all, we know that 4 centimeters corresponds to 10 values. So therefore we can say that, well, if we want to find the one, it's 4 divided by 10 is equal to 1 value, so that we can then convert that. So 4 over 10, which is equal to 0.4. So 1 value on here is equal to 0.4 on the x-axis. On this one here, we have 5 values. So we know that 1 value using the same scale is equal to 0.4 centimeters. So we're going to do 5 times 0.4, and that's equal to 2 centimeters. You could have also got this as well by saying, well, this 10 centimeters or 4 centimeters, so 5 values must be 2 centimeters because it's half of that. So this is 2 centimeters. The next thing we need to do is we need to find the height. And this is where it can get a little bit complicated. So the first thing we can do is you can say, well, in the histogram, if we were to draw a histogram here, so the class and the frequency density, the formula is the class width times the frequency density is equal to frequency. And this is a key formula that we will use here because what it means is basically that the width times the height, because the height here, the y-axis is frequency density, is equal to the frequency. So therefore we can use this idea here. We can say that, well, 4, which is the 4 centimeters times 6 centimeters is equal to 24 centimeters squared, and that's the equivalent of 15 values. So if we know what one of our, we have a frequency here, we don't know the area, so we can say that 24 over 15 centimeters squared is equal to 1 value, and then we're going to plug that one here, so we've got 13, frequency of 13, so 13 times 24 over 15 is equal to 20.8 centimeters squared. So that tells you the area of this class, essentially. So therefore we can then say, well, 20.8. We want to find the height, so we're going to divide by 2 because it's quadrilateral. So divide by 2, we get a height of 10.4 centimeters. So height is 10.4 centimeters. And that's it. So your answer here is going to be a width of 2 centimeters and a height equals 10.4 centimeters. Question part C, estimate the mean and standard deviation of a time spent watching television by these students. So here I'm going to redraw this graph. So we've got from 1 to 10, 11 to 20, 21 to 25, 26 to 30, 31 to 40, and 41 to 59. And we also need to put the frequency in. So the frequencies are 6, 15, 11, 13, 8, 3. And then we've got the midpoints. So the midpoints here, so the key thing here is actually I wouldn't put the midpoints in first, I'd put in the lower class bounds and the upper class bounds. So the lower class bound here is going to be 0.5, the lower class bound 10.5, 20.5, 25.5, 30.5, and 40.5, and the upper class bound being 10.5, 20.5, 25.5, 30.5, 40.5, and what was the last value? Last value is 59, so it's going to be 59.5. And then we find the midpoints. So the midpoint here is going to be 0.5 plus 10.5 divided by 2, so that's going to be equal to 5.5, 15.5, 23. I've actually realised we don't need to do this, but it helps you work. If you weren't given all the information in the question, you would have to approach it this way so that you would get all the correct midpoints. But of course, you're given the midpoints in this question, 50. Okay, so if you were to add the upper and the lower class bounds together divided by 2, you should get the midpoint answers. So the first thing we're going to do is we're going to find the frequency times the midpoint, because that will give us our fx. So frequency times midpoint is going to be 5.5 times 6, so it's 33. Of course, you can use a calculator to actually find this faster. So 23 times 11 is 253. 13 times 28 is 364. 35.5 times 8, 284. And 3 times 50 is 150. And then to find the mean, all we need to do for the mean here, the mean is equal to the sum of fx over n. Well, this is the same as the f times the midpoint. It's the frequency times the midpoint here. So the frequency is 6 plus 15 plus 11 plus 13 plus 8 plus 3, which is 56. And the sum here is 33 plus 232.5 plus 253 plus 364 plus 284 plus 150, which is 1316.5. So the mean is equal to 1316.5 divided through by 56. And that gives an answer of 2,633 over 112. So a rough estimate of 23.5. So that's the mean. The next step then is to find the standard deviation. So the formula for the standard deviation is given to you in the question. So if we go to the not in the question, sorry, in the formula sheet. So if we go down to the formula sheet and find the statistics, given the standard deviation here, we've got the sum of x squared, the square root of sum of x squared over n, or we've got this sx factor, which is probably more useful. So you've got the sum of x minus the mean all squared, or the sum of x squared minus the sum of x all squared. So the one that I would use is probably the sum of x squared, should be f of x squared actually, divided by n minus the mean squared. So what we're going to do is we are going to say that it's f times the midpoint squared, and so this is going to be 6 times 5.5 squared, which is 181.5, and then it's going to be 15.5 squared times 15, so again it's very long, 3603.75. Again, you should be able to do this on your calculator. So 5819, 13 times 28 squared is equal to 10192. 8 times 35.5 squared is 10082, and 3 times 50 squared is 7500. So here we add all of this up, so 181.5 plus 3603.75 plus 5819 plus 10192 plus 10082 plus 7500 gives an answer of 37378.25. And then we apply this into the formula. So the standard deviation formula is equal to the square root of the sum of f of x over n minus the mean squared. So it's the sum of f of x squared. So this is equal to the square root of 37378.25 divided by 56. subtract. Now here, keep your exact value for the mean. So 2633 divided by 112 all squared. So plugging that into your calculator, you get a result of 10.71. So around about 10.7 is fine. So that gives you your answer to part C. So it's 5 marks. Probably won't have to go into so much detail for the Edexcel exams, but it gives a good, if you can do this, then you can do any of the questions longhand. And it's a very important skill to be able to do. So it's definitely worth knowing this to build confidence and to understand exactly what you're doing and which formulas to apply. The next one is to use linear interpolation to estimate the median length of time spent watching television by these students. So linear interpolation, quite a tricky question usually. So first of all, the linear interpolation, we've got the median. So we've got 56 values. So the median value is usually, for this one, because it's an estimate, we don't need to use the usual median formula, which is the n divided by 2 plus 1. Here we can roughly say that it's going to be the 28th value. So it's equal to the 28th value. So the 28th value, we need to look at the table and work out where that is. So it's going to be, so we use a cumulative frequency at this point to find where this is. So this is, the first value is 6. Then you've got 6 plus 15, which is 21. And then you've got 21 plus 11, which is 32. So it's going to lie in the 21 to 25 class. And here you have to use a formula. Now, if you look at the statistics sheet, you're not given the linear interpolation formula. This is something that you'll have to remember. So just to show probability, standard deviation, discrete. But you're not given that one. So it's important that you can remember this, or you can use your own method to find it. So to find it, the formula is the lower class bound plus the median value, so the median, so in this case 28, minus the cumulative frequency before the class, divided by the number in the class. Times by the class width. So it's quite a complicated one to remember. So in this one, to see the values, so the lower class bound of a 21 to 25 one is 20.5, plus the median, which is the 28th one. The cumulative frequency before the class is 21, so 28 minus 21, divided by the number in the class, which is 11. And then the class width, remember the class width is going from 20.5 to 25.5, so it's 5. So we times that by 5. So then when we substitute that in, we're going to get 20.5 plus 28 minus 21 over 11 times by 5. We get a value of 23.7. And that's our estimate for the linear interpolation. And this is going to be the median. Now skewness is not on the course, but the teacher estimated the lower quartile and the upper quartile spent watching television to be 15.8 and 29.3, state giving the reason for the skewness of the data. So what we do for this question is we're going to say that Q1 is equal to 15.8, Q3 is equal to 29.3, and Q23.7, which is the median. So we compare the values, so Q2 minus Q1 is equal to 23.7 minus 15.8 is equal to 7.9, and Q3 minus Q2 is equal to 29.3 minus 23.7, which is 5.6. So we can see that this has a bigger distance between it, so therefore in this case it's a negative skew. because the difference between the median and the first quartile is bigger, but you don't need to worry about it for this question, for your exam. Okay, question 2 is a stem leaf diagram. We have 19 employees of a company. Take an aptitude test. The scores out of 40 are illustrated in the stem and leaf diagram below. So to find the median score in this one, you can do the long method like GCSE, start from the end, count down, but the fastest way is just to do 19 divided by 2 plus 1, which is the median for an odd n. So 19 divided by 2 plus 1, 19 divided by 2 and then round up. My apologies, that's the even one I've given you. So 19 divided by 2 is equal to 9.5. So therefore it's the 10th value that we're interested in. So we just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the 10th value here is 33. The interquartile range. So to find the interquartile range, we're going to do the same idea here. We're going to do 19 divided by 4 in this case, which gives you 4.75, and then here therefore is going to be the 5th value, so we round up. So this is for quartile 1, so it's 1, 2, 3, 4, so this value here is going to be 24 is quartile 1. And then you just add that number onwards. So we're going to add on, there's the 5th value, so we're going to add 5 values on from the median, so 1, 2, 3, 4, 5. So therefore quarter 3 is equal to 40. So the IQR is equal to 40 minus 24, which is equal to 16. So Q3 minus Q1. So again, to just repeat the method for part B, we do the n divided by 4, then round to the nearest value, round upwards to get the 5th value, which would mean you count 5 values to find where quartile 1 will be, and then to find quartile 3, you just add the 5th 5 values on from the median to find it. The company decides that any employees whose scores are so low that their outliers will undergo training. An outlier is observation whose value is less than 1 quartile, then the quartile minus 1 times the interquartile range. So here, scores are so low, so here we're looking at low scores, so we're looking really at quartile 1, which is 24, and an observation is a value who's less than who's less than the lower quartile minus 1 times the interquartile range. So that's saying that the outlier is equal to Q1 minus the interquartile range. So that's essentially where the outliers will begin. So Q1 is the 24, and then the interquartile range is 16. So 24 minus 16 is equal to 8, and we can see here that there is one value here. That is 7, so therefore 7 is the outlier in this case. And on the graph paper, draw the box plot to illustrate the employee scores. So for the box plot, again, we cannot include 7 in the box plot because it's been designated an outlier. So we have to star that one. So 5, 6, 7 gets crossed, and then we start our range. So we start off with 18. So 18 is the beginning of our box, so 18 is here, so that's the end. We then carry that on to quartile 1. Quartile 1 is 24, so that starts the actual box plot, and then that continues all the way through to quarter 3, which is 40. So it's going to continue there to 40, and that's Q3. and then we need to put the median in. The median is given as 33. So then we plug 33 in. 33, and there we go. And because 40 is the last value, there's no whisker, essentially there's no line afterwards. So this is quartile 3, this is the median, or quartile 2, this is quartile 1, and this is the range, and this is the outlier. And that's it for question 2. Question 3, the birth weights in kilograms of 1,500 babies are summarised in the table below. Write down the missing midpoint of the table. So this one is different from the previous question because we can see that we've got a 0 to 1, 1 to 2, etc. So they touch each other. Essentially, you don't need an upper and lower class bound here. So it's just generally the midpoint. So you're just going to add these two together. So 3 plus 2.5 divided by 2 gives you 2.75. And then the second one, the midpoint between 5 and 6, is just 5.5. Calculate an estimate of the mean birth weight. So for this one, you're just going to add a table here, f of x, and then just times it together. So it's 1 times 0.5 is 0.5, 6 times 1.5 is 9, 2.25 times 60 is 135, 2.75 times 280 is 770, 820 times 3.25 is 2,665, 320 times 3.75 is 1,200, 4.5 times 10 is 45, and 5.5 times 3 is 16.5. So then sub this together, it's 0.5 plus 9 plus 135 plus 7 plus 2665 plus 1200 plus 45 plus 10.5. You should get a total one of 4841. Oh, hang on. Ignore all of that. I misread the question, so the question's given it already here. So apologies for waste of time. So here you just need to be able to calculate the frequency, which is 1,500. So the mean is equal to the sum of f of x over n. You're given f of x here is 4841 over 1,500. Plugging that into the calculator gives you a mean value of 3.227, which is just going to be an answer of 3.23. Calculate an estimate of the standard deviation of the birth weight. So this one, standard deviation, is equal to the square root of the sum of f of x squared over n minus the mean squared. So we're going to plug in those values. So it's the square root of 15889.5 divided by 1,500 minus, now keep the actual values as much as you can. So 4,841 divided by 1,500 squared. Plug this in, we get an answer of 1,500 squared is equal to 0.4221, and we'll take that as a standard deviation. Use linear interpolation to estimate the median birth weight. So we do 1,500 divided by 2, which is equal to 750. So then we do a cumulative frequency to find which class the 750 value comes into. So this is 1, 7, 67, 67 plus 280, 347, plus 820 gives you 1167. So we know that is going to fall into this class to 3 to 3.5 class. So again, we use the formula for linear interpolation. So the interpolation formula is lower class bound, which in this case is 3 times, plus, sorry, plus what do we have here? So it's going to be 820, 1167 minus 750. Oh, no, my apologies. Sorry, it's not that one. So we're going to use the previous formula that we used before, which is the median value minus the CF before the class. Apologies. So the median value here is going to be the 750th value minus 347 divided by 820 times by the class width. Sorry, the class width, which is 0.5. So to remind you again of the formula, it's the lower class bound plus the median value minus the cumulative frequency before the class divided by the number in the class times the class width. So this is going to give you a value of 3 plus 750 minus 347 divided by 820 times 0.5. So that gives a value of 3.2457, which is 3.25 as the final answer. Again, with regards to this one, describe the skewness of the data, the distribution. This one is not in your syllabus, so you don't need to worry about this one. It is a negative skew because the mean is less than the median. Okay, question 4. There are 180 students at a college following a general course in computing. Students on this course can choose up to 3 extra options. And there's a list below. Draw a Venn diagram to represent this information. So for this one, we draw a big one here. And there's 3 options. There's system support, there is developing software, and there is networking. So for this one, so again, first thing you should always start with is take all 3 options, so you can fill that one in. So that's 4, and then from here you can work backwards. So you've got 40 taking systems support and networking. So that's going to be this one here, but 4 of those are taking all 4 options. So this one is just going to be 36, because take system support and networking corresponds to this little part here of the Venn diagram. So these have to add up to 40. The next one we've got is 28 are taking networking and developing software. So again, we're looking at this part of our one. So 4 of those students are taking all 3. So we do 28 minus 4, which is 24. And then finally 35 take developing software and system support. So that means 31 just take those 2, while the 4 students take all 3. 81 take networking. So to find this one, we do 81 minus 24 minus 4 minus 36, which is 17. We also have 70 take developing software. So it's going to be 70 minus 24 minus 4 minus 31, which is 11. And finally 112 take system support. So 112 minus 31 minus 4 minus 36. Okay, so you've got 41 in here. And then what you want to do is just add up everything in the Venn diagram to make sure that it adds up to 180. Which it doesn't, it's 164. So you have to do 180 minus 164, which equals 16, which is the number of students that don't take any options. So a student from the course is chosen at random. Find the probability that this student takes none of the extra options. So to take none of the extra options, we're only interested in this one here. So the answer is just going to be 16 over 180, which can simplify down to 4 over 45. And then networking only, so this one is just looking at the networking only one, which is this one. So it's 17 over 180, and you can't simplify that one down any further. A student who wants to become a technician takes system support and networking. Given that a randomly student wants to become a technician, find the probability that this student takes all 3 extra options. So students who want to become technicians take system support and networking. So system support and networking is this one here. So you've got 40 students that are in here. So 40 students, and you want to find the probability, because you're only looking at those students, given that a randomly chosen student wants to become a technician, so that means they study, or they have to study system support and networking. How many are doing all 3 options? So 4 out of the 40 are. So that means that 1 in 10 altogether are, and that's the probability. Okay, the last question for this video is question 5. The variable x was measured to the nearest whole number. 40 observations were given in the table below. The histogram was drawn, and the bar representing the 10 to 15 class has a width of 2 centimeters and a height of 5 centimeters. For the 6 to 18 class, find the width and the height of the bar representing this class. So it's very similar to the first question. We're going to we can draw this out. So again, be careful when you look at this one. Do they meet each other, or is there a gap between the numbers? Here we can see a clear gap between the numbers. So that means that they're going to look at the upper and the lower class bounds. So this is 9.5 for the lower class bound of 10 to 15, and the upper class bound is going to be 15.5. So 9.5 to 15.5 is equivalent to 2 centimeters. And then it's got a height of 5 centimeters with a frequency of 15. So what we can do first, we can find the width, because we can say that, well, 15.5 minus 9.5 is equal to 6. So there's 6 values, so 6 is equal to 2 centimeters. So therefore, 1 value is equal to 2 over 6 centimeters, which is equal to 1 over 3 centimeters. So from here we go to the next one. So the next class is 16 to 18. So again, we're going to use our class bounds for 15.5 to 18.5. So 15.5 to 18.5. This is worth 3 values. So it's going to be 1 over 3 centimeters times 3, because this is 1 value and we've got 3 of them. So it's equal to 1 centimeter. So the width is equal to 1 centimeter. Then we want to find the height. So we know that this has a frequency of 9, and we know from question 1 that if we find the area, we can then, the area is equal to the frequency essentially. So 2 times 5 is equal to 10 centimeters squared. So 15 is equivalent to 10 centimeters squared. So 1 value, 1 frequency is equivalent of 10 over 15 centimeters squared, which is equivalent of 2 over 3. So here we know we've got 9. So it's going to be 9 times 2 over 3, which is equal to 6 centimeters squared. Because we're doing the frequency times the 1, so this is 1 frequency essentially. We've got 9 here, times that 2 over 3, 6 centimeters, and then we know that it's going to be 3 times h is equal to 6 centimeters squared. So it's going to be 6 divided by 3, which is equal to 2 centimeters for the height. And that brings to the end the first 5 questions of this question set.